Okay, let's continue. So we looked at the geometry of addition of 2 points. So let's look at the geometry of scalar multiplication of points. So for example, we can consider scalar multiplication by -1. So if you have a point a equals a1 a2 like this, then -1 times a is just minus a1 comma minus a2. And for example, if you have a point -2 comma 3, then -1 times a is just 2 comma minus 3, right? So -1 times a is just 2 comma minus 3. So what we see is multiplication by -1 is just reflection about the origin. Right, so multiplication of by -1 just reflects the point about the origin. And so we can consider some other kinds of multiplication. So if you have a point a1 a2, capital A equals a1 a2, if you multiply that point by 1/3, what you get is a point where both coordinates are 1/3, made 1/3 of the original thing. So both coordinates are made 1/3 of the original point. So note that the distance has also become 1/3. Square root of 1 by 3 a1 square plus 1 by 3 a2 square is just 1 by 3 times square root of a1 square plus a2 square. So the distance from the origin has become 1/3. So note that the vectors are just directed line segments. So note that the vector OA okay, it's understood. So note that the vector OA, or I'll write it, has become 1/3 of its length and the direction is preserved. So multiplying this point A by 1 by 3. So if you, or let's not go into this. So you're basically, in some sense, the direction of the point is preserved. And the length, so, and the distance from origin or I'll just say length. So by length I mean distance from origin, becomes 1/3. 1/3 the original length. So Multiplying by 1 by 3 preserves direction but changes length to 1/3 of the original length. So in general, multiplication by a number r between 0 and 1, strictly between 0 and 1, intuitively it shrinks the point. It shrinks points. So both coordinates, if you multiply a point by a number r between 0 and 1, then both the coordinates will become r times the previous versions. So in some sense it will bring the point closer to the origin. So the length will become r times the original length and the direction of the point will be preserved. Okay, so this is what happens. So another example, just to so if you take this point is -2 comma -3. So if you scale it by, for example, half, then what you get is this point. So half times a is just -1 comma -3 by 2. So both coordinates have become half of their original versions. The distance from the origin has become half of the original distance, and the direction of the point, so to speak, has been preserved. The direction of this vector from origin to A. So direction, I'll write. So basically I mean direction of OA. This vector, this directed line segment. Yeah, in any case, yeah. Direction is preserved and the length has become half. Direction of the point has been preserved and the length of the point, so to speak. Direction and length are in quotation marks. So I think it's understood. So direction of this point has been preserved, but the length has been halved. So multiplication by 1 by 3, 1 by 2 has this effect. In general, multiplication by r, a real number r between 0 and 1, has this effect of shrinking the point towards the origin. Alright, shrinks points towards the origin. Okay. So what about, for example, multiplication by, so we looked at multiplication by -1, we looked at multiplication by real numbers between 0 and 1. So we can consider multiplication by real numbers greater than 1. So it's the same thing, it's just that, yeah. For example, if you have a equals a1, a2, if you take 3 times a, 3 times a is just 3a1 comma 3a2. So both coordinates have become 3 times the original coordinates, the coordinates of a, and multiplication by r greater than 1, in some sense it expands the points away from the origin. So multiplication by a real number between 0 and 1 shrinks points towards the origin, shrinks any point towards the origin, and multiplication by a real number which is greater than 1 expands the points, in some sense, away from the origin. It expands or pushes the points away from the origin. The length becomes 3 times the original length. So square root of distance from the origin is become 3 times, because square root of 3a1 square plus 3a2 square is just 3 times the original, 3 times the square root of a1 square plus a2 square. So distances, so in going from a to 3a, distance has become thrice and the direction has been preserved. So only multiplication by a negative number sort of flips the direction. And for example, multiplication by minus 2 is just multiplying by minus 1, that is reflecting about the origin, and then multiplying by 2. So yeah, so this is the geometry of scalar multiplication. Okay, so that's all for this part. See you in the next part.